Today, we are diving into the Sentence Transformers library. This is an absolutely amazing tool that helps computers do more than just read words. It helps them actually understand what those words mean. And we're going to break it all down with a little story, a tale of three very different models.
But first, let's start with a problem that I think we've all felt. Have you ever searched for something, let's say fast car, and the search engine completely misses a perfect result just because the page says speedy automobile? It's a super common frustration, right? And it happens because traditional search is just stuck looking for exact keywords.
And this is really the core difference. See, over on the left, keyword search is super literal. It's only looking for the exact phrase fast car. But on the right, you've got semantic search. It gets the idea. It understands that speedy automobile and quick vehicle are talking about the same thing. This is the magic that we're about to unlock.
So how do we actually do this? Well, meet our first character in this story, the BY encoder. It's also known as a sentence transformer. But for our purposes, let's just call it the Sprinter.
The Sprinter's whole job is to be incredibly, mind-bogglingly fast. It can take any piece of text you throw at it and instantly turn it into a list of numbers. We call that a vector, or an embedding. And because it's so quick, it's the perfect tool for massive jobs, like sifting through millions of documents or grouping similar things together.
I love this slide because it gives you a great visual for what's happening. Just imagine the Sprinter plotting every single one of your documents onto this giant meaning map. See, things with similar meanings get placed close to each other. So when you type in a search, your query just lands on the map and all the Sprinter has to do is find its closest neighbors. It's super fast and super effective.
And you know what the best part is? All of that incredible power is packed into one simple line of code. That's it, model.encode. You're basically just telling the model, hey, encode these sentences for me. And the Sprinter just goes. It's way more straightforward than you might think.
But look, speed isn't everything. Sometimes what you really need is precision. And for that, we need to bring in our second character, the cross encoder. Let's call this one the Judge.
Now, the Judge works in a totally different way. Unlike our speedy Sprinter, it doesn't create a separate map point for each sentence. Instead, it takes a pair of sentences, like your query and a possible result, and it compares them directly to come up with a single, highly precise similarity score. This makes it way more accurate, but also a whole lot slower. Why? Because it has to look at every single pair one by one.
So here's the bottom line. The Sprinter is your first pass, wide net kind of tool. It's fast, it scans everything on its own, and it gives you a big list of pretty good candidates. The Judge, on the other hand, is your specialist. It's slower, but it carefully compares those candidates to find you the absolute best match from that shorter list.
And this just shows you the Judge's power perfectly. For the query, a man is eating pasta, look at that. It gives a really high score, 0.67, to the very similar sentence, a man is eating food. But for something totally unrelated, like a cheetah is running, the score is practically 0. That is precision in action.
Okay, so what happens when you team them up? When you combine the raw speed of the Sprinter with the pinpoint accuracy of the Judge? Well, you get the ultimate search team, and you unlock a super powerful strategy called Retrieve and Re-rank.
Here's how it works. Step 1 is retrieval. The Sprinter just blasts through millions of documents and pulls out, say, the top 100 most likely matches. Then comes step 2, re-ranking. The Judge takes over, but, and this is key, it only has to look at those 100 candidates. It carefully examines each one and picks out the absolute best result. You get the best of both worlds, speed and precision.
The source material really says it best. First, a fast BY encoder finds a set of promising candidates. Then, a more powerful cross encoder re-ranks these candidates. It's a beautiful 1-2 punch. Speed first, then precision.
But wait, our story isn't quite over yet. There's a third character, one with a completely different playbook. Meet the sparse encoder. We're going to call this one the Librarian.
So, what makes the Librarian so different? Well, the Sprinter creates what we call dense vectors, where pretty much every number in that list has a value. But the Librarian creates sparse vectors, where almost all the values are just 0. The few numbers that aren't 0 act like little tags, and they often point directly to important keywords. It's a totally different way of thinking about meaning.
So why would you use the Librarian? Well, for one thing, those sparse, keyword-like vectors are a lot easier for us humans to understand, but the real magic happens when you combine them with traditional search engines. This lets you create something called a hybrid search, where you're blending classic keyword matching with the deep semantic understanding of our other models. You really get the best of everything.
So there you have it. That's our tale of 3 models. Let's pull it all together and take a look at the brand new AI toolkit you now have at your disposal.
Here it is, nice and simple. You've got the Sprinter for your fast, large-scale search. You've got the Judge for that super accurate re-ranking of your top results. And you've got the Librarian for interpretable, efficient hybrid search. 3 different tools for 3 very distinct but related jobs. And what's maybe the most amazing thing about all of this is that you don't have to build any of these from scratch. There are over 10,000 pre-trained models just like these, ready to go, on platforms like Hugging Face. You can literally download one and start building powerful stuff with it today.
So I guess there's really only one question left to ask. Now that you have the tools to teach machines to truly understand meaning, what are you going to build?